Have you ever wondered why things fall to the ground or why the moon doesn't just drift away into space? It's all because of gravity. Gravity is one of those invisible forces we rarely think about, but it's literally everywhere, affecting everything from the way you walk to how planets move in space. But what exactly is gravity and how does it work? Let's break it down in a way that's easy to understand, and I'll try to give you examples from everyday life as well as what's happening way out in space. Okay, so at its most basic level, gravity is the force that pulls objects toward one another. You can think of it as the glue of the universe. Anything that has mass, that's just a fancy word for how much stuff is in an object, also has gravity. That means you, me, a car, even the Earth. All of these things have a gravitational pull. But here's the thing, the larger the object, the stronger its gravity. That's why Earth has enough gravity to keep you and me on the ground. But a basketball doesn't pull you toward it when you're holding it. Earth is huge, so its gravity is strong enough to keep everything grounded. Now, when we talk about gravity, we have to mention Sir Isaac Newton. Back in the 17th century, Newton was the one who came up with the idea of gravity being a force that pulls objects toward one another. There's even a famous story that a falling apple inspired his thinking about gravity. Though it might be just a story, it's a nice way to think about how he connected what he saw around him to bigger ideas about the universe. Newton figured out that the strength of gravity depends on two things: how much mass the objects have and how far apart they are. The more massive the objects, the stronger the pull. The closer they are, the stronger the pull. Think about it like this. If you're standing next to a big truck, the Earth's gravity is pulling you both toward the ground, but because the truck has more mass than you, it feels heavier. If you moved far away from the truck, the gravitational pull between you and the truck would become weaker. So while gravity is always at work, its strength changes based on the size of objects and the distance between them. But gravity isn't just about things falling. It plays a huge role in space too. For example, have you ever looked up at the moon and wondered why it doesn't just float away? It's because Earth's gravity is constantly pulling the moon toward us. At the same time, the moon is moving forward at a speed that keeps it in orbit around Earth. It's a delicate balance. If the moon weren't moving, gravity would pull it down to Earth. And if Earth had no gravity, the moon would drift off into space. So gravity and motion keep the moon in its orbit, just like gravity keeps the planets moving around the sun. One of the coolest real-world examples of gravity is the way it affects the ocean's tides. You've probably seen how the water level changes at the beach. Sometimes the water comes up high on the shore and sometimes it pulls way back. That's because of the moon's gravity. Even though the moon is much smaller than Earth, it's still massive enough to have a noticeable gravitational pull on the oceans. As the moon orbits Earth, it pulls the water toward it, creating tides. Without gravity, there wouldn't be any tides at all. Now, while Newton's ideas about gravity were groundbreaking, another scientist, Albert Einstein, took it to the next level in the 20th century. He thought of gravity not just as a force, but as a way that mass bends space itself. Imagine space as a big rubber sheet. If you place a heavy ball on the sheet, it creates a dip or curve. That's kind of what happens with gravity. Massive objects like planets or stars warp the space around them. And that's why smaller objects like planets follow curved paths around them. It's a tricky idea to wrap your head around, but it helps explain some of the strange things we see in space. Take black holes, for example. A black hole is like the ultimate gravity monster. When a massive star collapses in on itself, it creates a black hole, an area where gravity is so strong that nothing, not even light, can escape it. If you think about space being like that rubber sheet again, a black hole would be like poking a hole through the sheet. Everything nearby gets sucked into it because the gravity is just too intense. Speaking of space, understanding gravity is absolutely essential for space exploration. When NASA sends rockets into space, they have to think about how to escape Earth's gravity. To get a rocket out of Earth's gravitational pull, it has to reach a speed of about 11.2 kilometers per second. That's around 25,000 miles per hour. If it's too slow, gravity will pull the rocket right back to Earth. Once a spacecraft is in space, scientists use gravity to help it along its journey. They use something called a gravity assist, which is when a spacecraft flies close to a planet and uses the planet's gravity to slingshot itself further into space. It's a clever way to save fuel and extend the reach of missions. One famous example of this is the Voyager spacecraft, which NASA launched back in the 1970s. Voyager used gravity assists from planets like Jupiter and Saturn to accelerate and change direction, allowing it to travel all the way to the edge of our solar system and beyond. Without gravity, none of that would be possible. But gravity isn't just something we deal with here on Earth or in space. It's also responsible for the way the universe looks today. Right after the Big Bang, gravity pulled together clumps of gas and dust to form stars and galaxies. Over billions of years, gravity shaped everything we see in the night sky. And here's something mind-blowing. Scientists believe that most of the gravity in the universe comes from something we can't even see. They call it dark matter. And while we can't detect it directly, we know it's there because of the way it affects the movement of galaxies. Even though we know a lot about how gravity works, it's still a bit of a mystery. For example, while Einstein's theory of gravity explains how it works on big scales, like with stars and planets, it doesn't fit with what we know about tiny particles in quantum physics. Physicists are still working to figure out how gravity works at the smallest levels, and cracking that mystery could change everything we know about the universe. In everyday life, gravity is something we don't usually notice, but it's always working behind the scenes. It's the reason you stay grounded, why objects fall, and why you feel weight. If you were on a planet with stronger gravity than Earth, like Jupiter, you'd feel much heavier because Jupiter's gravity is stronger. On the flip side, if you were on the Moon, you'd weigh much less because the Moon's gravity is weaker. Astronauts on the Moon can hop around easily because of this weaker gravity. So, whether it's helping us understand the motion of galaxies or just explaining why we don't float away when we jump, gravity is an essential force in the universe. It's a concept that might seem simple at first. Things fall, planets orbit, but the more we learn about it, the more complex and fascinating it becomes. And even though we've known about gravity for centuries, there's still so much to discover. The more we study it, the closer we get to unlocking the deeper secrets of our universe. In short, gravity is like the universe's invisible hand, shaping everything from the fall of an apple to the dance of galaxies billions of light years away. It's one of the most fundamental forces, and without it, life as we know it wouldn't exist. So the next time you drop something or gaze up at the night sky, take a moment to think about gravity. It's always there, silently working its magic.